Dr. Trufan, and in this video, we are going to perform an experiment that allows us to compare the behavior of a dilute strong acid solution with a pH of approximately 5 to a buffer solution with a pH of approximately 5 when a strong base is added to both of them. So for this experiment, we're going to use a dilute hydrochloric acid solution with a pH of 5, and by now you should have all the skills you need to make this solution on your own independently. Here we have a buffer solution that we made with acetic acid and sodium acetate that has a pH of approximately 5. And for the experiment, we're going to use a 1 molar sodium hydroxide solution, and we're going to add 5 drops into each of these two solutions to see the ability of these two to resist changes in pH as a result of the base addition. As an optional experiment, you may use a universal indicator, which you can add 2 drops of into each solution and see the resulting color. If the pH of the two solutions is similar, the two colors should also be very similar. And in this case, we find that both are a yellow-amber color. For the experiment, to know exact values for the pH, we're going to use a pH probe. The pH probe will need to be rinsed with deionized water between transfers. And that water will be collected in a waste container. Because I am using a wireless pH probe, it needs to be connected to a device, and today that device will be my iPad. And finally, every time we rinse our pH probe, we need to use a gentle Kim wipe to dry it off before we move it into another measurement. So let's get started. The first thing we're going to do is extract our pH probe from its storage container. Rinse it with a generous amount of deionized water. And wipe it dry. Then we're going to place our pH probe into our dilute hydrochloric acid solution. Keep it there for a couple seconds, at least 30, and record the associated pH. The pH of our dilute hydrochloric acid solution is 5.12. And measure the pH of our buffer solution, which again should be approximately 5. The pH of our buffer solution is 5.03. Now we rinse our pH probe and place it back into its storage container temporarily. Next, we will use a pipette to add 5 drops of 1 molar sodium hydroxide solution to both our beakers. 2, 3, 4, 5 drops of 1 molar sodium hydroxide solution in the hydrochloric acid containing a beaker, and 5 drops, 1, 2, 3, 4, and 5 drops of the 1 molar sodium hydroxide solution in our buffer. We set them aside. We swirl the contents of our beakers to make sure that our solutions are homogeneous. And we are going to compare the color of the two solutions. We can tell that the pH of the dilute hydrochloric acid solution changed substantially, and the pH of the buffer is likely very similar to what it originally was, despite the fact that we added 5 drops of the 1 molar sodium hydroxide solution. So now let's see numerically how our pH values changed over time. We extract our pH probe from its container, rinse it thoroughly with deionized water, dry it with a Kim wipe, and then submerge it in our formerly dilute hydrochloric acid solution, which is now likely very basic. its pH is already 11.72. So we'll record the pH of our solution as 11.7 and submerge it into the formerly buffer solution that had the 5 drops of 1 molar sodium hydroxide added to it. Originally, the pH of this solution was 5.03, and now the pH is 5.03. So it resisted changes in the pH, even though we added the 5 drops of the 1 molar sodium hydroxide solution.